Hello, Math 45 students. This is your instructor, Cindy Enrique. We are going to pick up on page 23. So this is section 2.6, and this is other types of equations. So sometimes we have to solve for higher power equations. And so what we can do, in particular for this first one, is that we can factor. Well, when I factor, I have to make sure that I have all the terms equal to 0. So I'm going to subtract the 16x squared on both sides. So I can get a 4x to the fourth minus 16x squared is equal to 0. So notice how the first step, I just subtract that 16x squared to both sides. Now I'm going to have my GCF. So the GCF here is 4. And the smallest exponent that they both share is an x squared. So I know that my GCF is going to be that 4x squared. So I'm left with an x squared minus 4 equal to 0. So the inside here is going to factor as a difference of squares. So I have x plus 2 and x minus 2. And I can't forget that I still have the 4x squared on the outside. So now what I do is I set each parentheses equal to 0. So I have my 4x squared is equal to 0. So really, this tells us that if we divide by 4, I get x squared is equal to 0, and the square root will give me to 0. So I have my first answer as x is equal to 0. Now I have my x plus 2 is equal to 0. So x is equal to a negative 2. And then that last parentheses, x minus 2 is equal to 0. So x is going to equal to a positive 2. So I'm going to have my three answers. My three answers being x is equal to 0, x is equal to negative 2, and x is equal to a positive 2. Now, let's go ahead and look at the second example. So when I look at the second example, I see that I have 1, 2, 3, 4 terms. So when I see that I have 4 terms, the best way to solve this is going to be factor by grouping. So the first thing you always want to check is there a GCF that lives in all of them? There isn't. So I'm going to go ahead and split it. So the first two, they have an x squared in common. So I'm left with x plus 3. There's an addition sign that gets dropped down, and 7 is in common in the last two terms, so I have an x plus 3. Notice how we have our common parentheses, which is x plus 3, and whatever is left over goes in its own set of parentheses, so x squared plus 7 is equal to 0. So I have that x plus 3 is equal to 0, so that x is equal to a negative 3. That is going to be one answer. I also have x squared plus 7 is equal to 0. So then x squared is going to equal to a negative 7. And if I were to square root both sides, don't forget the plus or minus. So I can get that x is equal to plus or minus the square root of negative 7. And of course, that's going to be imaginary. So that's going to be plus or minus I square root 7. So here I have x is equal to plus or minus I square root 7. It depends really on your homework whether or not it would accept this. It may or may not accept it, so I want to be careful. Homework may or may not accept imaginary answers. So I just want to make sure that you guys are aware of that it could or could not accept it for your homework. So hopefully you guys will figure that out once we get into the homework. Now we have a U substitution. So for this U substitution, usually the x to the fourth, well, that's very difficult to factor if I don't have 4 terms. So what we're going to do is we're going to use a little, I don't want to say a trick, but maybe a method. One of that method is to use a substitution. And usually in, calculus and whatnot, we do the substitution as a U substitution. So we usually want to look at this middle term. So we want to look at this x squared. So we are going to say that U is equal to x squared. Okay. So if I were to square the U, that would be x squared squared. So that would be an x to the 4th power. So now I'm going to rewrite this. So remember, I originally had x to the 4th minus 8x squared minus 9 is equal to 0. And now with that substitution, that x to the 4th is really u squared. I have minus 8. And that u squared is really u minus 9 is equal to 0. So now I can factor this. And some of you still like the AC method, and that's fine if that is your preferred method. Remember here, my A value would equal to 1, my B value is negative 8, and my C is equal to a negative 9. So I would have negative 9 on top and a negative 8 on the bottom. So that would give me a negative 9 and a positive 1. So these two would multiply to negative 9, but add up to a negative 8. So because the leading coefficient is 1, I know this is going to factor as a u minus 9 and a u plus 1. So now I set each thing equal to 0. So u minus 9 is equal to 0. So then u is equal to a positive 9. I also have u plus 1 is equal to 0. So that u is equal to a negative 1. But remember, u is not what we started with. We started with x. So at this point, we're going to have to do a back substitution. Okay, so in order to do our back substitution, we're going to look back at our original definition. Remember that we had let that u was equal to an x squared. So if I have u, that's really x squared is equal to 9. So in order to get rid of the square, I'm going to do the square root. So now I would have x is equal to plus or minus the square root of 9. So then x is equal to a positive 3, and I have that x is equal to a negative 3. So now I have two different answers. And I'm not done. I still have that u is equal to a negative 1. So doing our back substitution, that u is really x squared, and it's equal to a negative 1. So to undo this, I am going to square root both sides. And don't forget the plus or minus. So now I have that x is equal to plus or minus the square root of negative 1. Well, I know that's just plus or minus I. So x is equal to a positive I, and x is equal to a negative I. So I end up getting 4 different answers. And again, you want to be careful of whether or not the Newton homework will allow you to put in imaginary numbers. But this is definitely the right way to think about it. Okay. Now for my next example, I'm looking at this and remember the best thing that you can do is think about this middle term. This middle term is going to tell you what the u substitution is going to be. So here I'm going to have that u is equal to x minus 5. So then u squared is going to equal to x minus 5 squared. So I have x minus 5 squared plus x minus 5 minus 2 is equal to 0. So my substitution with that u minus 5 squared, that's a u squared. Plus that u minus 5, I said was going to be my u term, minus 2 is equal to 0. Again, if you like the AC method, then that's fine. You want two numbers that are going to multiply to a negative 2 and add together to a positive 1. So you're going to get that with a positive 2 and a negative 1. So I'm going to factor this as u plus 2 and u minus 1 equal to 0. So now I can say that u plus 2 is equal to 0, so that u is equal to a negative 2. I also have u minus 1 is equal to 0, so that u is equal to a positive 1. Remember, now we have to do the back substitution. And that back substitution was that u is equal to x minus 5. So that u now becomes our x minus 5, and that's equal to a negative 2. So if I add 5 to both sides, that's going to give me a positive 3. So I'm going to get that x is equal to 3 as one of my answers. Now I have that u is equal to 1, so I'm going to have x minus 5 is equal to a positive 1, so then x is going to equal to a positive 6. So I get x is equal to 3 and x is equal to 6. Okay. Going on to our next section, we are now going to be able to solve these radical equations. So to solve these radical equations, the first step, it says to isolate the radical expression on one side of the equal sign. Put all remaining terms on the other side. So step number 1, the square root is already isolated. So that's perfect. So step number 1 is done. If the radical is a square root, then square both sides of the equation. So this is definitely square root. So I'm going to square both sides of the equation. Okay. And it says to, for step 3, solve the remaining equation. So the square root and the square cancels. So I'm left with a negative 2x plus 8. Now I have an x squared. So I'm going to subtract everything to make it equal to 0. So add 2x minus 8 plus 2x minus 8. So now I have 0 on one side, and it's going to equal to x squared plus 2x minus 8. So then from here, I'm going to go ahead and factor. And again, if students like the AC method, that is totally fine. A times C would be negative 8. My B is a positive 2. So that's going to be a positive 4 and a negative 2. So I'm going to have x plus 4 and x minus 2. So I'm going to have x plus 4 is equal to 0. So x is equal to negative 4. I'm going to have x minus 2 is equal to 0. So x is equal to a positive 2. And you always want to make sure that you check your solution in your original equation. So I solved it, and nothing repeated. So confirm solutions by substituting them into the original equation. That's step number 5. So if I have my calculator, here it is, I'm going to plug that in, that negative 4. So I have the square root of negative 2. That x value that I'm plugging in now is negative 4 plus 8. So when I press enter, it should give me the x value. The x value should be negative 4. It's a positive 4, not a negative 4. So this answer doesn't work. So, okay, that's fine, but let's try the next one then. So I have the square root of negative 2. The x value that I'm plugging in now is 2 plus 8. So when I press enter, this should equal to 2. And it does, and it's a positive 2, which is exactly what we wanted. So the only possible solution that we have is x is equal to 2. The x is equal to negative 4 was a possible solution, but when we plugged it in, it did not work, so we throw it away. We don't like that. Okay, so now let's go to our next example. So we're going to do the steps all over again. So that's what we're going to do. We're just going to keep going. So step number 1, isolate the radical expression on one side. Perfect. Done. Now I'm going to square both sides. So square and square. So when I square both sides, the square root and the square cancels. So I am left with my 8x minus 23 is equal to, and now I have x minus 2 times x minus 2. So I'm going to have to go ahead and FOIL that, which would give me x squared minus 2x plus 4. So 8x minus 23 is equal to x squared minus 4x plus 4. So now I have squared both sides, and now I want to solve for x value. So I am going to subtract 8x and add 23. So subtract 8x and add 23. So when I do that, I'm going to get 0 on one side, x squared, negative 4 and negative 8 is a negative 12x. Positive 4 and positive 23 is going to give me a positive 27. And from here, I'm going to factor. And of course, if you like to do the whole AC method, that's fine. Let's see. 1 times 27 would give me 27, and I want to add up to a negative 12. So that would give me a negative 9 and a negative 3. So I have x minus 9, x minus 3. Negative 9 times negative 3 is a positive 27. Negative 9 plus negative 3 is a negative 12. So now I know that x minus 9 is equal to 0. So x is equal to 9. I have that x minus 3 is equal to 0. So x is equal to a positive 3. And again, you always want to check, plug it into your original equation. So if I plug this into my original equation, let's start with number 9. So I have the square root of 8 times, oops, let's try that again. So I have 8 parentheses, the x value, which is 9, minus 23. So that gives me 7. So I'm going to plug that x into the opposite side of the equation. So I'm going to have 9 minus 2. So that should give me 7. If these are both equal, then we can say that it's one of the solutions. Perfect. 9 minus 2 is equal to 7. So both sides are equal to 7 when I plug in x is equal to 9. So that tells us that that is going to be a perfectly legit answer. Okay. So we can go ahead and try this again for x is equal to 3. So I have the square root of 8 times 3, that's the value I'm plugging in, minus 23. So that's equal to 1. So we're going to plug 3 into the x minus 2. So 3 minus 2, it should be equal to 1. And if both sides are equal to the same number, then that is an acceptable solution. So we say that we have two solutions. We have x is equal to 9 and x is equal to 3. After we checked it into the solution. Okay, now for this one, this last problem here. For this one, you have to be really careful. There's actually, what's different between this one and the other two, if you want to just take a little, snapshot of it, is that here, for this example, you have two radical expressions, versus in the first two, you only have one. So this one, I'm going to write as small as possible, and may even have to use some of this extra space over to the side. There's a lot going on here. So remember, the first step, I want to isolate the radical if possible. So that means I'm going to subtract one of the radicals to the opposite side. So I'm going to have this as a negative x plus 4 square root is equal to 3 minus the 5x plus 1 square root. So now I subtracted that square root, which is perfect, which allows me to square both sides. So the square root and the square cancels, so I'm left with negative x plus 4. But now on this opposite side, I have two sets of parentheses. So 3 minus the square root of 5x plus 1 times 3 minus the square root of 5x plus 1. which tells me that I'm going to have to FOIL this. So I'm going to have 9 minus 3 square root 5x plus 1 minus 3 square root 5x plus 1 is equal to, oops, not equal. And then the square root of 5x plus 1 times the square root of 5x plus 1 should be plus 5x plus 1. Because the square root gets squared, it's the exact same thing. So now I'm going to have a negative x plus 4 is equal to 9 plus 5x plus 1 minus 6 square root 5x plus 1. So what I ended up doing here is I combined this negative 3x and that negative 3 square root and that negative 3 square root. So negative 3 and negative 3 gives me my negative 6. So now I'm going to clean this up just a little bit. 9 plus 1 is 10, and I still have my 5x minus 6 square root 5x plus 1. So what I'm going to do here is I'm going to subtract the 10 and subtract the 5x. So that'll give me a negative 6x. Negative 6 is equal to negative 6 square root 5x plus 1. Now, the really cool thing about this is since I have a negative 6 that's being multiplied, I can divide it. So now I'll have an x plus 1 is equal to the square root of 5x plus 1. Okay. So now, since the process is repeating, I'm just going to rewrite it. So x plus 1 is equal to 5x plus 1. So now it went from 2 radicals to 1 radical. So now don't forget to square it. This is where I'm repeating the process. So I really have x plus 1 times an x plus 1 is equal to 5x plus 1. And so when I do that, I am going to get that this is x squared plus x plus 1 is equal to 5x plus 1. Combining like terms, I will have a 2x plus 1 is equal to 5x plus 1. So I am going to subtract 5x from both sides and subtract 1 as well. When I do that, I get the x squared minus 3x is equal to 0. From here, I can factor. So x is the GCF. So I'm left with x minus 3 is equal to 0. So x is equal to 0. And x minus 3 is equal to 0. So x is equal to a positive 3. Whew, that was a lot of work. It was a lot of work, but it was doable. And we're not quite done yet. So the next thing we need to do, remember, is to check our answers. So if you check your answer, so go ahead and grab your calculator. If you check it, you're going to see that x is equal to 0 works out. That's fine. But the x is equal to 3, when I plug it back into my original equation, it does not check out. So the only possible solution that we have here that works out is x is equal to 0. Okay. So now we want to deal with rational equations which lead to quadratics. So what we want to do is we want to factor as much as possible the denominator. So here we have 6, that would be 2 and 3 if they're both. Actually, that will not work. So sometimes you do guess and check. So this is going to be 6 and 1. There we go. It's going to be a negative 6 and a positive 1. Yep, that works. So now I know that my LCD would be an x minus 6 and an x plus 1. Perfect. Now what I'm going to do is I'm going to multiply each fraction, each term by this, by the LCD, by what it's missing. And what happens when you do that is that the denominators are going to drop. So notice how that first numerator, I have negative 2x minus 7. The next thing that I'm going to multiply it by, well, if I already have an x minus 6, which is here, The thing that's missing is the x plus 1. So I'm going to multiply that by x plus 1. The next thing I have is a negative 4. And I have to multiply that by what's missing in the denominator. So notice how this is x plus 1. So what's missing is the x minus 6. Now it's equal to 2. And that green denominator has an x minus 6. And it has an x plus 1. So it has both of those things in the denominator. So you're not missing anything. So you're fine. So now I want to go ahead and distribute. So that first one, I'm going to have a negative 2x squared minus 7x minus 2x minus 7. And I'm also going to take this negative 4 and distribute inside the parentheses. So that's going to give me a negative 4x, and a positive 24 is equal to a positive 2. Now rearranging this, I'm going to have a negative 2x squared, and I have a negative 7x, a negative 2x, and a negative 4x. So all of that combined gives me a negative 13x. And I also have a negative 7 and a positive 24. So that's going to give me a positive 17. And that's equal to 2. So now I'm going to subtract 2 from both sides. So now I have negative 2x squared minus 13x and a positive 15 is equal to 0. Now from here, what you want to do is you want to combine like terms, or actually make that leading coefficient positive. That'll help me out. So I'm going to multiply everything by a negative 1. That's going to give me a positive 2x squared, a positive 13x, a minus 15 equal to 0. And that makes my life a little bit easier when I factor. And so now, factoring, hopefully you guys are getting comfortable with factoring. You can definitely do the AC method if you prefer, or you can do guess and check. For me, I'm going to do guess and check. I know that I'm going to have 2x times x. And if I'm thinking about 15, I'm going to have 15 and 1. So positive 15 and a negative 1. And that definitely works out. So I'm going to rewrite it over here. 2x plus 15 and x minus 1 is equal to 0. So 2x plus 15 is equal to 0. So 2x is equal to a negative 15. So x is equal to a negative 15 halves. For my other possible solution, x minus 1 is equal to 0. So x is equal to a positive 1. And when you plug these both back into the original equation, they both work out. So I have x is equal to a negative 15 halves. And x is equal to a positive 1. Okay. So let's go down to our next example. Let's see if we can figure this one out. Again, I'm going to try to factor this, but it looks like it's already kind of factored, right? I already have x plus 3 and x minus 6. So x plus 3 and x minus 6. So that would give me a negative 6 and a positive 3, which is a negative 3. And positive 3 times negative 6 is a negative 18. Perfect. So now I know for a fact that my LCD is going to be x plus 3 and an x minus 6. So again, I'm going to take my first numerator. I'm going to multiply by what's missing in the denominator. So I have x plus 3. So what's missing is the x minus 6. Now I have an x minus 6. So I'm going to have plus 2x plus 1. And what it's missing, since I has the x minus 6, the missing part is x plus 3. And that's going to equal to 5. And nothing is missing from that denominator, so we just leave it alone. So now I'm going to distribute and try to make sense of this. So I have a negative x plus 6 plus 2x plus 1. Oops, I forgot that I was foiling here. I went too fast and furious. So when I'm foiling, I'm going to have a 2x squared plus 6x plus x plus 3 is equal to 5. So I have my 2x squared. That was the only squared term. I have an x, and an x. So the negative x and the positive x cancel, so you're left with a positive 6x. Now it looks like you have a positive 6 and a positive 3. So positive 6 and positive 3 is going to give you a positive 9. And it's equal to 5. I want that to equal to 0, so I'm going to subtract 5 from both sides. So I can get 2x squared plus 6x plus 4 is equal to 0. And when I do this, I see that each term is divisible by 2, so that's going to be my GCF. My GCF is a 2. So I'm going to factor that out. I would get an x squared plus 3x plus 2 is equal to 0. So that makes it a lot easier to factor. So multiplies to 2 is 2 times 1, and if they're added together, it adds up to 3. So I have x plus 2 is equal to 0. So x is equal to negative 2. And I also have x plus 1 is equal to 0. So x is equal to a negative 1. Okay. And when I plug those both back into my equation, I get that x is equal to 2 is a legit answer, and x is equal to negative 1 as a legit answer as well. Okay. Now we're going to be moving into the solving absolute value equations. Okay. So what we know is that if we have an absolute value of x on the number line, it tells us how far away it is from 0, okay? So we never really say the absolute value of x is equal to a negative value. We just say that the distance, since distance is always positive, it's always going to be a positive number. So we have some rules here. And so what we want to make sure is that we understand this. So rule number 1. If the absolute value of x is equal to 0, then my x is equal to 0. The second rule that we want to think about is that if the absolute value of x is equal to, let's say, something that's not 0, then we have two different options. So the two options is that x is equal to positive 3, and the second option is that x is equal to a negative 3, okay? So that's the difference here, is that it can be 3 or negative 3 if it's a value that's not equal to 0. And if it's equal to the absolute value is equal to a negative number to begin with, then we say it's going to be no solution. So let's think about these rules as we try to solve them. So here it says solve the absolute value equations. So here I have the absolute value isolated, it's equal to 8. So I'm going to break it down into its two different options. So the first option is that 6x plus 4 is equal to 8. My second option would be that 6x plus 4 is equal to the negative of that value, which would be negative 8. So now that I have my two different equations, now I'm going to set them up. So I'm going to have So I'm going to have 6x is equal to 8 minus 4, which is 4. Now divide both sides by 6, so x is equal to 4 over 6. So x is equal to 2/3. That is going to be one of my answers. Now for the second one, I'm going to subtract 4 to both sides. So that 6x is equal to negative 8 minus 4, which is a negative 12. Now I have to divide by 6. So negative 12 divided by 6, well, that's going to give me a negative 2 as a possibility. So now I have my two answers, x is equal to 2/3 and x is equal to negative 2. Now I look at part B. If I'm looking at this answer, I have an absolute value equal to negative value. Whenever I have an absolute value equal to a negative number, this automatically cannot be done. We say no solution. This is not possible. Okay. So let's look at part C. The absolute value is not isolated, so I'm going to have to add 4 to both sides. So I have 3x minus 5 is equal to 10. So now I have to do my first answer, which is going to be 3x minus 5 is equal to 10. And I'm going to have my second answer, which is 3x minus 5 is equal to the negative of it, which is a negative 10. So I have 3x is equal to a positive 15, and x is equal to 15 divided by 3. So x is equal to a positive 5. So x is equal to a positive 5 is going to be my first answer. For the second one, I'm going to add 5 to both sides. So negative 10 plus 5 is a negative 5. So I'm going to have that my x value is equal to a negative 5 divided by 3. So x is equal to negative 5/3. Now for part D, what's really nice about this is that it's already equal to 0. So 0 is neither positive nor negative. So we're allowed to drop the absolute value now, because the absolute value of 0 is just 0. So I have negative 5x plus 10 is equal to 0. So I have negative 5x is equal to negative 10. So x is equal to a negative 10 divided by negative 5. So x is equal to a positive 2 for my final answer. Okay, well, I hope this is making sense. The next section, we want to solve for our complex nth roots. So for something like this, I'm looking at this, and I can think of this as a perfect square root. So the square root of 64 would be 8. 8 times 8 is equal to 64. Also, if I have 6/3 squared, that gives me an x to the 6th. So this is really x to the 3rd plus 8 and x to the 3rd minus 8 equal to 0. So that is my difference of squares. Now, hopefully you guys remember your sum of cubes and your difference of cubes, because that is what we're going to apply here. So for our first one, our sum of cubes, that would be x plus 8. Oops, not x plus 8. What's the third root of 8? 2 times 2 times 2 is 8. So it would be x plus 2. So I'm left with x squared minus 2x plus 4. So that comes from the first one. Now the x to the 3rd minus 8. Well, since it's subtraction, then it would be x minus 2. So that would give me an x squared plus 2x plus 4. And all of that is equal to 0. So now I have each one equal to 0. So maybe I'm just going to rearrange it so it's a little bit easier on the eyes. I have my x minus 2. I also have, oops, that was really x plus 2. And I also have my x minus 2. And I also have my x squared minus 2x plus 4. And I have my x squared minus 2x plus 4. and all of this is equal to 0. This step wasn't necessary, but it makes it a little bit easier for spacing. So now I can say without a doubt that x plus 2 is equal to 0. So x is equal to a negative 2. So that is going to be one of my answers. I also have that x minus 2 is equal to 0. So x is equal to a positive 2. That is going to be another answer that I have. Now, what remains is that x squared minus 2x plus 4. That cannot factor anymore. So what I want to do is use the quadratic formula. So that negative b plus or minus b squared minus 4ac all over my 2a. So I have that, if I'm looking at my x squared minus 2x plus 4, I have a is equal to 1, b is equal to negative 2, and c is equal to a positive 4. So when I plug that in, I'm going to get that x is equal to a 2 plus or minus the square root of negative 12 all over 2, which can be reduced to 2 over 2 plus or minus I square root 12 over 2, which tells me that this is 1 plus or minus I square root 12 over 2. So that is going to be one of my answers. The other answer that I have was in green. Again, I'm going to do the substitution. So if I have this the quadratic equation. So if I have x squared plus 2x plus 4, I know that my a value is 1, b value is 2, and my c value is going to be equal to a positive 4. So when I plug this in, I'm going to get that x is equal to my negative b value, so that is going to give me a negative 2, plus or minus, and I did this on my calculator already, b squared minus 4a times c. So 2 squared minus 4 times 1 times 4 gives me a negative 12. Okay. And it's going to be divided by 2 times a, which is a 2. So x is equal to a negative 2 over 2 plus or minus the square root of negative 12 divided by 2. So x is equal to negative 1 plus or minus I square root 12 over 2. And so that is going to be my other possible solution. So x is equal to negative 2, x is equal to positive 2, and x is equal to that negative 1 plus or minus, and also the x is equal to 1 plus or minus. So those are going to be my 4 solutions. And really, I want to skip part B. We don't have to get into that. So hopefully that makes sense. And if you guys have any questions, please email me.